Howdy, this is Reed Ham with TECO Westinghouse Motor Company out of Round Rock, Texas, and we're going to be taking a look at our portable vibration analyzer here and looking at some of the features, how to set it up, how to install the accelerometers, how to then go ahead and acquire data, and then how to look at the app on board a mobile device to be able to interpret the data and do some reporting. We're going to take that step by step and see how that works. First, we're going to look at the setup here. It comes with two accelerometers, one for each end of the motor. You'll see here they're mounted to the top. Normally on NEMA mounting, you'd want them on the bearing housings in the correct orientation, but on this particular motor, the end housings are aluminum, so these magnets won't stick. So we have to put them here on the top. It also comes with our unit here has a temperature probe on the side, and that's going to be picking up temperature off of the contact where it is on the motor. It is a USB plug for all of the sensors out there. This one I have plugged into a battery, but it also comes with an adapter for the unit to plug into the wall, or out in a facility somewhere you can have a battery backup that you can carry with you. It's quite portable. So the setup here is this is a motor. We've installed a balance weight or an imbalance weight here on the shaft extension, so it's going to give us some vibration. And we have one of our VFDs, our variable frequency drives, here attached to it, so I can kind of vary the input on that unit and get some different vibrations, so we can take a look at those readings. Now, once you have the app downloaded and the unit's powered on, we're going to have to connect to it in the Wi-Fi screen here on the Wi-Fi connection. You see I've already chosen it from the list, the TCOM device there. And then once that is connected and the Wi-Fi is available, then you can come over here and open the app. It'll make the short connection. You have an option here. Most of the time, of course, we're set up to monitor motors because that's what we manufacture, but in case you have another unit there, gearbox, pump, compressor, you have an others option that you want to analyze. It brings up a list of things there. You can use a transmission shaft or a fan, and then you can enter the data there and take measurements on those as well. But we're going to be set up here for motors, so we'll go in here to the motor. You can see from the list here, your device name, number, your measurement points, power, voltage, current, poles. We can go down the list, your drive mode, variable frequency drive, your loaded condition, is it loaded, unloaded, what kind of foundation it's on. So all that data is entered, and then you're able to take the measurements. Okay, so I've entered some data here. You can see the nameplate information here, up and down. You select the installation, foundation, elastically mounted, originally mounted. That'll change your vibration limits or alarm limits. Input frequency, because it's a variable frequency drive. Go ahead and hit next. It gives us a couple of options. We can do real-time measurements or the analysis. We'll go ahead and do the real-time measurement first. And that's actual live data there on the first device, and then the second one, you can go here, and then you can actually get the temperature there, 74 degrees. So as you go through these, you can choose these and look at the overall trends, X, Y, Z. This is RMS levels of each side. I can go up here at the top on the gauge and then change that to velocity spectral data. I'm going to go through it real quickly and pull a velocity spectrum, or get the acceleration as we watch. If you change speed, then we're going to go up there and increase the speed. Take it up to about 45 hertz or so. So my vibration has changed, but my spectral data has not moved. So I'm going to go in here and just refresh that. And go ahead and take another one for us. And now you can see my information has changed there. So go back to the RMS. Now we're obviously the vibration is quite a bit higher, right? So, and we'll go ahead and turn that back down. So that's kind of the real-time analysis. And you go back and you can do the measurement and go through the full setup, take an RMS, FFTs. You start that analysis. It takes it a second, and it'll go through. It'll pull the RMS values. It'll pull the spectral analysis off there too. Measurement's complete. That's the first point, so now it's going to go to the second point. Pull that data as well. See, it just takes a second to pull that through. Measurement complete. So now it gives us just kind of an overview, and then it'll give us a opportunity to take a look at the diagnosis. It tells us the RMS is normal, so everything's good to go. If instead that we go back and we take that measurement and that vibration is a little high, right, we're going to go through the measurement analysis. When we start measuring here, we go through the same setup, but now we have vibration that's quite a bit higher this time. Complete that one. Go ahead and go into the next one here. Now it's telling us our RMS is abnormal, so we're going to go in here and we're going to go into our diagnosis. It's just in case you're not that familiar with vibration analysis. It'll give you some things to check for. You go through one at a time, and it tells you down here at the bottom what to look for in the kurtosis. Does it look like bearing defects? We're going to say no. And now we're going to say check for imbalance. Large vibration at 1x turning frequency. Say that's a potential yes. Check misalignment. It gives us some information there. We're going to say no. Check for soft fit there. We're going to say no. And then check for loose parts. We're also going to say no. So now we have a potential defect there identified. It tells us what the defects in the treatments to do. Now we want to measure the temperature. I'm going to say yes. It gives us a standard limit that we can adjust. So I'm just going to go ahead and run it through. It grabs the temperature reading for us. Measurement complete. It has a temperature of 76. Tells us the temperature's meeting the standard value. Now it just gives us a chance to look at all this, all the kurtosis, which is a measure of the waveform, of the peakiness of the waveform, to see if there's any problems with the bearings, that kind of thing. Temperatures, overall limits, gives us the diagnosis. Now output format. So we're going to go down here and we can either change that from Excel to a PDF. So I'm going to choose PDF for now. And I'm going to save that. It says it's saved successful. Now I can share it. I can go in here and this is what it's going to look like. It's going to give me kind of an overview. It's going to give me on the measurement point 1. It's going to give me the FFT of one axis. Measurement point 2. Same thing here. Down here at the bottom it says I have abnormal results. My RMS is over the limit. My temperature is normal. My diagnosis that I had put in there is possible imbalance. Maintenance advice, it tells me what to do, and I have a chance to place to sign it there. So now I can send that report. I can either send it by mail, I can save it here to my files, I can create a PDF, copy it to iBooks, that kind of thing. So I have a lot of places to do it. I can airdrop it if I want to. A lot of places to send that out. I can just simply mail it, and it mails a PDF copy. Or I can go back and save it as that Excel sheet, which it just saves the tabulated data, which you can go ahead and adjust later. So it's kind of an overview. It's intended to be fairly portable. To take it out to the field, it has the battery backup to it. The app is very intuitive. You can kind of step through the process there. You can see here, there's not that many wires. You just need one for each accelerometer and then the power cord, and it's set up very much like a modem. If you wanted to do a stationary mount, it also comes with a DIN rail mount. You can see it is magnetic. It will stick to a magnetic surface. On the back side there, it has the DIN rail mounts. So that way you can mount it to a box or whatever if you wanted to mount it to do kind of a continuous monitor on a piece of equipment that was giving you some trouble. You can see over here on the motor itself, those devices, they have magnets with the rails on them that work well on curved surfaces. Does affect your vibration readings, but not enough to make it the day-to-day operation. It's okay. You can measure up to about 2,000 hertz with those. Pretty effectively. They're pretty strong magnets, and then temperature sensor is also magnetic there. There's a magnetic mount. So that's kind of the overview and how it works. It works pretty well. I mean, it's fairly portable. So look forward to hearing any feedback that y'all can get. Thanks.